In this video, we're going to talk about scatterplots. Before we dive deep into the world of scatterplots, I do want to talk about these two types of variables. So, first is a response variable. So that measures an outcome of a study. An explanatory variable may help predict or explain changes in a response variable. So we're going to be talking about quantitative variables here, not categorical. So these are pure data, number things. So a little note here, sometimes you'll see explanatory variables as the independent variable, which usually goes on the x-axis, and that would mean that response variables are dependent variables or go on the y-axis. But because in mathematics we use independent and dependent for plenty of other things, in stats and for our intents and purposes, we're going to call them response and explanatory variables. What are new words and definitions without putting them into context with an example? So, in this video, we got some highly intriguing, weird kind of examples to work through. Anyway, this one's called diamonds in the SAT. No, they're not handing out diamonds when you go to take the SAT, although they should. So, we're going to take two different scenarios here. We're going to identify the explanatory variable and the response variable. So, first one is the weight in carats and the price in dollars for a sample of diamonds. Which one is the response and which one is explanatory? So here's what we would say. The explanatory variable is the weight and the response variable is the price. And here's why. The weight of a diamond helps explain how expensive it is. Now let's take a look at the SAT math score and the SAT evidence-based reading and writing score for a sample of students. Which one is explanatory? Which one is response? Did I get you with that one? Either variable could be the explanatory variable because each one could be used to predict or explain the other. So math score doesn't necessarily inform the reading and writing score and vice versa. All right, so now we're getting into the meat of this video. What's a scatterplot? Well, here's what it does. A scatterplot shows the relationship between two quantitative variables measured on the same individuals. The value of one variable appears on the horizontal axis, boop, and the values of the other appear on the vertical axis. Each individual in the data set appears as a point on the graph. I bet you've seen a scatterplot before. It's literally what it sounds like. So here's how you make a scatterplot. You're going to draw and label your axes, and remember the horizontal axis is the explanatory variable and the vertical axis is your response variable. So from there you scale the axes, you make equal marks on both of them, cover all your data points, all your numbers, and then you plot individual data values. So for each individual, plot a point directly above that individual's value on the horizontal axis and directly to the right of that individual's value for the variable on the vertical axis. A lot of words, but we're going to work through an example so you can see exactly how those words come together. All right, we've got a baseball example for you here. Less intriguing than diamonds in the SAT, but so the problem says, do baseball teams that spend more money on players also win more games? The table shows the payroll in millions of dollars and number of wins for each of the 30 MLB teams during the 2016 regular season. So let's make a scatterplot to show the relationship between payroll and wins. Here's the data that we're going to be working with, all of our 30 teams here. Payroll, remember, in millions of dollars, and wins, which are not in millions. That would be crazy. So remember the three key steps here. Label the axes, so I have our axes drawn, scale the axes, and then we're going to plot our individual points. So let's label these things. Our explanatory variable is going to be payroll in millions of dollars, and our response variable up here is going to be number of wins. So next I'm going to scale the axes. First thing I'm going to point out here is that you don't necessarily have to start at 0, but something that we kind of like to do is that if you're not starting at 0, you kind of make that notch a little bit further. So the payroll, the lowest number that I found was 71, and it went all the way up to 274. So roughly between 50 and 300, counting by 50, is going to be that scale on the payroll axis. And then for the number of wins, the lowest that I found was 59. The highest was 103. So I'm thinking between 50 and 110. I split those up. I scaled that by 10. So we go from 50 up to 110. So the last and arguably the most important thing to do is to plot individual data values. So what I'm going to do is plot every single payroll. So for example, the Arizona Diamondbacks, I would find 103, so that'd be roughly right there, and its wins was 69, so I'd go 103 up to about 69, put a point right there, and that's how I'm going to do all of them. So let's see what that looks like. All right, she's not perfect, but she'll do. So what I make sure to do is that every time that I plot a point, I put a point or a slash or whatever next to it so I know that I've plotted it. Another thing while you're plotting is you might want to have like a piece of paper or a ruler or something to help you kind of line up where that point should go, especially if you're doing it by hand. Grid paper obviously is hugely beneficial. I didn't put that down here. I'm a cotton-headed ninny muggins. And then also try to count your dots and make sure that it lines up with, the number of data points that you have. But here we go. There's a scatter plot. So while a graph, like a scatter plot, is all beautiful and wonderful to look at, it's really kind of useless if you don't analyze it and try to glean something from it. So scatter plots have 3 different types of associations. There's positive, negative, and no association. 2 variables have a positive association when above average values of one variable tend to accompany above average values of the other, and when below average values also tend to occur together. So this is an example of a positive association, and that's of the scatter plot that we just made. So it really is telling you that it has a positive association, which means that teams that spent more money typically won more games. So if a positive association has above average values pairing up with other above average values, so both of your axes agree with each other, a negative association is when they tend to disagree. So 2 variables have a negative association when above average values of one variable tend to accompany below average values of the other variable. So here's a negative association graph. That would be a negative association because this says that teams that allow their opponent to score more runs typically win fewer games. So again, this one's positive because we've got some lower numbers here that also agree with the lower numbers over here. Same deal with higher numbers tend to agree with the higher numbers on the other axis. And then a negative association, if you have a low number on one axis, the point is actually going to exist on the higher values, and vice versa, where you have a higher value but a lower value on the other axis. So that's positive and negative association. And of course, when you don't have positive or a negative association, you've got no association. So that happens between 2 variables when knowing the value of one doesn't help you predict the value of the other. So this is a good example of no association, where you can't really make any conclusions one way or the other. Now there are 4 major categories when describing a scatter plot. There are 4 characteristics to make sure that you cover. First is direction. So a scatter plot can show a positive, negative, and no association. We just covered that. Form. Now a scatter plot can show a linear, right, a line, or a non-linear form. The form is linear if the overall pattern follows a straight line. Otherwise, it's non-linear. Then there's strength. So a scatter plot can show a weak, moderate, or strong association. So an association is strong if the points don't deviate much from the form that's identified. So if it's a line, most of the points tend to make a line. And if it is not a line, then most of those points make not a line. An association is weak if the points deviate quite a bit from the form identified. So last thing is any kind of like unusual features. So those are outliers and distinct clusters of points. Something else to note is even when there's a clear relationship between 2 variables in a scatter plot, the direction of the association describes only the overall trend, not an absolute relationship. Let's put that into practice with another example. Sorry. This example is called Old Faithful and fertility. Never thought you'd hear those two things in the same sentence. So this problem says, describe the relationship in each of the following contexts. So we've got two graphs here. The first one maps to this guy. So the scatter plot on the left shows the relationship between the duration in minutes of an eruption and the interval of time upon the next eruption in minutes of Old Faithful during a particular month. And then over here has nothing to do with Old Faithful. That scatter plot shows the relationship between the average income and the fertility rate in 187 countries. So let's take the first one, the one about Old Faithful, and describe it using these four things. So I'm going to use these four categories to really make up an explanation here. First, I'm looking for direction. Now that's either positive, negative, or no association. So this is positive. That would be a positive linear slope, which brings me to its form. It's pretty linear. I know it doesn't look like a straight line, but it makes a line if you were going to draw a line of best fit through it. Strength, real strong. The points don't deviate much from the form indicated. There's not a whole bunch of other things happening out here. It's just boop, straight. And then unusual features, there's not a lot of outliers here, so I wouldn't say that there's outliers, but there are two distinct clusters, one here and one here. So we're not done with this description. I'm going to turn all of this information into more of a paragraph. So let's do that. So here's one way to phrase it. There's a strong positive linear relationship between the duration of eruption and the interval of time until the next eruption. There are two main clusters of points. One has durations around 2 minutes, and that occurs with intervals around 55 minutes. So we just went into the middle here of that cluster. That's how you would describe it. And the other cluster is around 4.5 minutes with intervals around 90 minutes. Now let's do the same thing, but with the relationship between average income and fertility rate. So here's what I would say. The direction here, that's definitely not positive. And it's not no association, so that's going to be a negative association. It's not linear. It's really curved. You can't draw a straight line through that and hit, most of the points. The strength, I would say, is moderate. And this one might be a little bit difficult to see, but there's one outlier. Now, you might think it's down here, but really that's just like a tail over here. There's an outlier over here because there's a big old clump of numbers here. These ones are close enough, these guys are close enough, and those are okay. This one seems to be way out there at about 30K and maybe 4.5, almost 5, as far as the fertility rate goes. So let's put that into a couple of sentences. So here's one way to phrase it. There's a moderately strong negative nonlinear relationship between the average income and fertility rate in these 187 countries. There's a potential outlier with an average income of about $30,000 and a fertility rate around 4.7. So the last thing I want to show you is how to make a scatter plot using your TI 83 or 84. So if we take the information from those baseball teams with their payrolls and their wins, what you want to do is you want to hit the stat button. You want to edit your lists. So if you've got 2 brand new lists to go in there, L1 is your payroll. You can leave it 103, 122, etc. Just knowing that that axis is in terms of millions of dollars. And then L2 can just be the wins. Double check your data. You probably know that by now, but always double check it. Type those values into our lists, and then you're going to hit second y equal to turn on your stat plot, plot 1, turn it on, pick the very first graph type that's going to make a scatter plot. You're going to want your x to be L1, your y to be L2, or whatever your lists are that you type them into. You can make any mark you want. You can pick any color you want. If your calculator can do that, you can adjust whatever settings you want. And then you go to zoom and zoom stat, and then you hit graph, and there you go. There's your scatter plot. Now that looks a heck of a lot better than what I drew by hand. So another little thing to remember is don't just copy a graph, whether it's a scatter plot or not. Don't just copy it down. Actually know what you're graphing and what the intervals are and all that good stuff. All right, I bet you are feeling hella good. Get it? It's a No Doubt reference. All right, that's it. Thanks for watching.